Last time, we were talking about these flags, and I said I would look up InnoDB locks unsafe for bin log. And it's complicated, which is why I did not actually put it in my own notes, because it's complex. I should have put in my notes C website, C manual. And basically, what it does is InnoDB row-level locks are really index-level locks, because the indexes are primary key clustered. So it just actually does a lock on the index. And so what it usually does, it does what's called a next key lock, which means it locks not only that index, that key, but the next one. So it gets that next one. And by default, it does that. But if you want to change that, you can set it to 1, which causes this next key gap locking to be disabled. And so it will only use index record locks for searches and index scans. It won't use this next key locking. So the effect is similar to, but not identical to, setting the transaction isolation level to read committed. So again, so that's why you might want to use it, is it does certain things of, what values you're going to see when you query things. But it does, in fact, so it says enabling InnoDB is a global, locks unsafe for bin log is a global session effect setting and affects all sessions, whereas the isolation can be set globally or individually per session. So probably it's better to set the transaction isolation level instead as a session basis, as opposed to this on the whole server. Yeah, it can be only set for the startup and all that kind of things. So it's basically saying, don't use locks unsafe for bin log, just change the isolation level. So that's well said. Again, I've never changed this, and I've done some pretty heavy lifting. So other people may have, they may have done heavier lifting or different heavy lifting, but that's just my experience. So again, that's kind of advanced tweakiness. So these are some flags that you might actually change, or at least the first one. So InnoDB adaptive hash index. So InnoDB has an adaptive hash. What's an adaptive hash? It's an adaptive index. It makes this adaptive index based on index searches you've done, and it will actually use some of the buffer pool memory to do this. It's actually pretty cool. And again, it's adaptive, so it tries to adapt to your needs. In 5.0, I forget which version now, we discovered a bug, actually. I actually did the bug report, which is how I know about it, where this InnoDB adaptive hash was broken, and it actually ended up using a lot of overhead and not actually helping anything. So it added overhead not just because it used some of the buffer pool pages to store the adaptive hash, but also making the adaptive hash, and it wasn't helping. So they couldn't fix, the MySQL engineers, the InnoDB engineers actually couldn't fix it right away. So what they did in the very next release is they put this flag to turn it on or to turn it off. So for the people that were experiencing problems with it, the flag was, they said, okay, turn it off. So some people did that. And then in the release after that, they actually fixed the bug. So probably you won't need to turn the InnoDB adaptive hash index off. But if you are finding that it's not really worth your while, you can, first of all, you can test it by turning it off and doing your load testing or whatever, seeing if it helps or if it hurts. In most cases, it will hurt because the adaptive index, the hash index, is actually a good thing, unless it's not, right? Unless there's a bug. InnoDB checksums, these are actually a safety feature. It's not like a checksum. So, by the way, MySQL has a feature called checksum table, which gives you a numerical checksum of the table. It will lock the whole table while you do it. MyISIN table actually has a feature in, starting with 5.0 actually, which again, found by writing the book. It actually has a feature where you can set the table to say checksum equals 1, and in the show table status and information schema, it actually has an updated checksum. Whenever you insert, update, or delete, it updates the checksum. So that's one way to get a checksum of a table without having to run checksum table and locking it. It has this running checksum. That's MyISIN only. So this InnoDB checksums is not like a checksum table thing. I told you that to tell you that this isn't what it is. InnoDB checksums is actually a safety feature. The default is on, and it basically says you might want to turn it off if you're, say, benchmarking or something. which to me doesn't make sense because if you're only turning it off for benchmarking, don't you want to benchmark what you're doing on production? I don't know. I think it's one of those, if you're trying to get every last bit of speed out and don't care about safety, you might want to turn it off, but I don't see how benchmarking means you want to turn something off that you turn on in production. I think you want everything to be exactly the same as in production and then benchmark. But there you go. ENODB auto-increment lock mode. So the default is 1, which is consecutive lock mode. That ensures that when you have insert statements where you don't know how many rows you're inserting in advance, and where you have auto-increments, all auto-increment values assigned by any insert-like statement are consecutive, and operations are safe for statement-based replication. Okay? If you set it to a ENODB auto-increment lock mode of 2, it means it's interleaved, right? It's not consecutive, it's not sequential, it's interleaved. It's not good for statement-based replication because, again, it might say, okay, you're going to get this, then this, and then you're going to get that, and you're going to get that. And when inserts are done, they get rid of the binary off. So you might start something here and here and here and here, and you might end it over there. The lock mode of 0 is actually the way that it was before this feature was introduced in 5.1.22, and you can actually test it for backwards compatibility. You know, it's for testing the backwards compatibility. I guess they don't recommend you turn it on. I guess they've decided that the consecutive auto-increment lock mode is better, but they don't actually explain how it's different from what it used to be. So, like I said, there were a whole bunch of ENODB flags. Hold on a sec. I'm actually going to set my timer for 10 minutes. I set my timer for about an hour from now so that we don't run into the problem last time. I was like, oh, we got 10 minutes, let's rush through the rest of the slides. Okay. So, ENODB force recovery. So force recovery, you only set force recovery if you're trying to recover from a crash. So by default it's 0, and it's always going to be 0 unless you've just restarted it by trying to, by turning it on and trying to force recovery. If you need to force recovery, it will be fairly obvious. MySQL or ENODB won't start. Usually MySQL crashes too when that happens. And so basically MySQL won't start, and when you look at the error log, you basically get this big long error that says, there's a problem with ENODB, try forcing recovery. Here's the URL to the MySQL manual page on how to force recovery. So you can actually see what the different levels do. There's actually there's 7 different levels, 0 and then 1 through 6. And basically each level kind of disables yet another feature. So basically you could bring the ENODB up just so that you can export with MySQL dump the data itself, and then you can re-import because something's crashed. So for example, if the index is corrupt and corrupt beyond repair, you might, I don't remember exactly which setting that is, but you can still export the data and then create a table, and it will just ignore it and say, don't worry about the indexes. Therefore, it won't give you an error and it won't crash, and you can still recover your data that way. ENODB table locks on and ENODB support XA transactions. That's just the default. You probably don't want to turn those off. ENODB table locks means, I think it means, I'm pretty sure, 95%, can you use lock tables? And by default, ENODB does row level locking, but, so it doesn't do by default table level locking unless that's what you specify. So I don't know why you want to turn it off because you have to specify a table lock anyway. More flags. This is the last page of flags. And obviously ENODB lock wait timeout is not a flag, right? It's a numerical setting. But ENODB rollback on timeout is in fact a flag. So you need the timeout to know when you're going to roll back. So basically, the question is, if you have a timeout on a lock wait, are you going to roll back or not? Okay? Now, that's not really the question. That's what it looks like. Okay? The question is, what is it going to roll back? Is it going to roll back just that statement, or is it going to roll back the entire transaction? Okay? Now, what on means, if it's on, if ENODB rollback on timeout means, it means the entire transaction rolls back. Okay? If there's a timeout. If it's off, which is default, only the statement that had the deadlock is going to be rolled back. Right? So let's say you're trying to, you're taking money out of your ATM, right? So you're taking out of checking and putting into savings, right? You want that to be a transaction. $100 comes out of your checking, $100 goes into your savings, right? If it crashes in the middle, you've taken $100 out of your savings, out of your checking, but you lost it. It didn't get into your savings yet, right? So let's say you have, your website or whatever your process takes out of your checking and then has a deadlock on your savings because somebody else is putting money in. Everybody's saving right now, right? Do you want it to roll back the fact that I took the $100 out, or are you going to try it again? So the default is you think, well, you would try it again. You're not going to roll back the entire transaction. Either way, it's a full transaction and it's ACID, but it is atomic because you're either rolling back the whole thing or you haven't committed the transaction. You're never going to really lose that thing. It's just a question of, do you have to redo everything else in the transaction before that deadlock happened, or do you just have to redo that one statement when the deadlock happened? Most of us want to just redo that one statement where the deadlock happened. Timed mutexes. This is, it's off by default. I wish it were on by default. Basically, when you have a mutex is a mutual exclusion lock, and basically if you have this on, and you do a show engine enodb mutex, you will actually see the time that it has been locked in milliseconds. Which, who knows why they haven't done it by default? Maybe it creates a lot of overhead or something. That's not in the documentation. But I would like it to be on by default because it could be pretty useful to see how long these things are locking for. Unique checks is on by default, so this is a session variable only. If you set it to off or 0, large table imports in enodb might be speeded up, but you might actually have uniqueness violations, right? Because it's not checking for uniqueness. So if you know that if you know you're doing like a MySQL dump import, right, then you know that you're not going to have uniqueness violations. But if you just turn it off, again, it's per session. Just turn it off for your session and start randomly inserting things, you might actually have uniqueness violations, which would be a bad thing. Even if you set this to 0, by the way, it was set to 1, which is the default. The uniqueness checks are done for the secondary indexes in the enodb table. But even if you set it to 0 and you turn it off, the storage engine might still check for them and might still issue a duplicate key if it detects it. So I don't know why. I think by storage engine, that's from the manual. I think what they mean is the storage engine itself. Because MySQL has different levels, right? Like enodb does foreign key checking. That's inside the storage engine. There's no MySQL checking of foreign keys. It's not done in MySQL. It's done in enodb, right? MySQL's optimizer is in MySQL, but the statistics generation is done in the storage engine. Right? So enodb stats are approximate, and the actual index dives aren't so good to get a good representation. But the way that the optimizer chooses it is not something that you can. It's not on the storage engine level. So I think what it's saying is that on the MySQL level, there might still be uniqueness checks. I don't think I would turn this off. This seems like one of those, you could make it a little faster if you really wanted to, but you might cause a disturbance in the force, so probably not a good idea. More people are laughing at that one. Great. I have a great yarn joke for later, by the way. enodb double write. So the enodb has a double write, which means that before it writes pages to the data file, it first writes them to basically a contiguous area of a table space called the double write buffer. Only after it's written to this double write buffer and the double write buffer is flushed, then enodb will write the pages to memory, right, to the proper positions in the data file. So if the operating system crashes in the middle of the page write, it's still in that double write buffer. So you have this ACID compliance, right? You have this durability that even if it dies in the middle, you'll still have it. If you didn't have that and the server crashed when you're in the middle of writing a page, you just go to the page and you're like, okay, that's what I have because everything else was in memory and it didn't work. So this is a good thing to have. You could turn it off. I don't recommend it. If you really don't want that feature, use MySQL. So this is also how many writes have you done with the double write buffer, and how many actual pages were written. So obviously multiple pages per double write on average. So some concurrency variables. One thing you know about enodb is concurrency, right? Enodb thread concurrency is, on this particular server, set to 16. The maximum value is 1,000. 0 will disable actually checking thread concurrency, so it's kind of unlimited. It's however many we happen to create. So basically, after this many OS threads are in InnoDB, so InnoDB has its own kernel, they call it. And so basically, after this many threads get into the kernel, you can't have any more. Now, there's a very complicated system of what threads can get in. So you can actually have more than 16 InnoDB queries going at one time. What happens is, you see this InnoDB concurrency tickets, 500. What happens is, in order to basically make it so that smaller and shorter queries can happen and longer queries don't take up all the CPU cycles and whatnot, what happens is every query gets, by default, 500 tickets, and that's how many times you can, yes, in fact, enter InnoDB. I wanted to say enter the InnoDB kernel. That's how many times you can enter the InnoDB kernel without having to go into a queue. So basically, you get 500 free passes to go in. And I don't know exactly how many operations that is. I don't know how big or small the query that is. I don't know if every query has 5,000 tickets or if it's only really big queries that need more tickets. But basically, your first 500 are free. After that, you have to wait in the queue. You only have to wait in the queue if the threads exceed the value of this InnoDB thread concurrency. So basically, if you're on the ride, right, and there's nobody waiting in line, you can stay on the ride. If there are people waiting in line because you've reached this, concurrency and then it's in the queue, then you have to, get off after the first 500 rides, I guess, right, because with these free tickets, the 500 tickets. So in this way, a longer query isn't going to eat up all of the cycles of the InnoDB kernel being used, right? Because smaller queries can kind of go in, do their business, and be done because they get their 500 tickets. Whereas longer queries have to, they have to wait in the queue, and then they go on, and they have to wait in the queue again. InnoDB commit concurrency, 0 is for unlimited. Why you would ever change that variable, I don't know. InnoDB thread concurrency, and this is an interesting thing, because you might say, well, let's make it bigger, because we want more concurrency, or let's make it 0 because it's unlimited and it won't check for it. But here's the thing. If you are doing a lot and you allow a lot of threads to come in, you're going to tax your CPU, you're going to start, swapping in and out processes because you have your CPU is maxed out, it's got to pick one thing to work on. So sometimes, the manual actually says, you should change this value to see if it helps to change it. You could increase it or decrease it. So again, if you decrease thread concurrency, I'm going to explain this a little bit because it's kind of anti-intuitive, right? If you decrease the thread concurrency, you might get through it faster. Imagine you write the Hyatt line, okay? The Hyatt line, when you go to check in, there's 2 desks, and the concurrency is 2, right? Now imagine if the concurrency was like 8, and there's only 2 desks, and everybody has 4 people at once yelling at them. It's going to take them a lot longer, not yelling, but saying, can I check in? It's going to take them a lot longer to do that, right? Because in their brains, they have to the context switch or whatever, right? So it's better for them to actually have a lower concurrency, because each transaction, the throughput is faster per transaction, right? That's the same thing here. So sometimes decreasing it is actually better. What are good values? They say start with 1 per CPU, and then kind of in there. For me, that's kind of the analog to 1 per desk. We go from there. So increase or decrease, play around with it. It's unfortunately, there's no magic formula. To say, oh, well, if it's this, then you need to increase it a lot or decrease it a lot. It's hard, and it's also, again, very misleading because you're like, well, I want unlimited concurrency. It's not like commit concurrency. Commit concurrency is that thing where you're like, no, just unlimited. I don't want to limit that at all. You might actually want to limit the number of threads inside the InnoDB kernel. So, InnoDB sync spin loops. So here's the thing. If you have the mutual exclusion locks on things, basically, I want something and you want something and you have it. What I'm going to do is I'm going to end up going into this waiting queue, and I'm going to spin for a little bit, and I'm basically going to say, okay, how many times am I going to wait for this mutex to be freed before I then suspend the thread? So I'm in the kernel, and I need something, and you're in the kernel, and you have it. How many times am I going to wait before I'm like, you know what? I'm not going to wait. I'm going to sit in the queue and I'm going to come out of the InnoDB kernel and be, suspended for a little bit, just as if I ran out of concurrency tickets and had to wait in the queue. That's 20 times by default. In show engine InnoDB status, there's actually something that says sync spin loops. There's OS waits and sync spin loops, and changing this value actually changes the balance of those two things. So if you want more spin loops and less OS waits, you can increase this. If you want fewer spin loops and more OS waits, you can decrease it. And why would you want to do that? You might want to do that because every time you do an OS wait, you are context switching. So you might want more because you might want less context switching. Or, you might realize, okay, I don't know, maybe the InnoDB kernel's taxed, so you want more spin loops so that it keeps staying. And you want fewer spin loops so that it goes to the OS more often. InnoDB buffer pool. Probably everybody knows what's on this page, so it's a refreshing break from what we were just talking about. InnoDB buffer pool size. That's the size of the RAM memory that's going to be used for InnoDB index and data. Everything gets put in there. We actually had recently a bunch of clients come to us and be like, "Oh, our tables are so slow." We're like, "Well, what are you doing?" And they're like, "Well, we have this like logging thing, and every time somebody clicks on anything, it gets logged to this table. And the table is InnoDB. Now, InnoDB basically does 2 writes for every write, right? It writes to memory, and then eventually later it writes to disk. Whereas MySQL just, boom, goes right in the disk, right? The data, the index has a cache and gets flushed eventually to disk, so the index actually does get written twice, but the data just, boom, goes right to disk. So, it actually makes it sound boom. So, when the server's really loud, it's all that booming from the inserts. Thank you for smiling. Thank you, thank you. My jokes get worse as the day goes on. I had no jokes this morning, I'm sorry. The thing is, we said, well, just switch to MyISOM and do concurrent insert equals to 2, and your writes will go much faster than they did. So, InnoDB isn't always the best for everything, but I told you that because basically sometimes having the index isn't a good thing. If you just really need it to go to disk, if you're always writing and never reading, it's more useful to have, MyISOM where you can do concurrent inserts. There are not concurrent updates or reads, unfortunately, in MySQL. So the InnoDB page size, by default, is 16 kilobytes. You want this to be a multiple of your page size, of your memory page size. And you also want it to be a multiple of your disk page size, because if not, if the disk page size is larger, or it's not a multiple, you're going to end up with wasted disk size or wasted memory, right? Because you pull up a page into a memory page, right? So if you pull up a 16 kilobyte page into 4 kilobyte memory pages, great. If you have 5 kilobyte memory pages, then you're going to end up putting into 4 5 kilobyte memory, 4 5 kilobyte memory pages, because 3 5 kilobyte memory pages would be 15 kilobytes, which is not 16 kilobytes. So you would actually have 4 kilobytes of wasted space because you're using 5 kilobyte data pages in Linux, right? Your memory pages, and 16 is not a multiple of 5. In addition, if you've ever used ZFS, the default page size on ZFS is 128K. Now what this means, it's much larger. What this means is that when you bring up, when you have a disk page and you're, say, probably reading or writing from disk, you write 16 kilobyte, write an InnoDB 16 kilobyte page to the disk, but it actually has to write the 128 kilobytes to ZFS, because that's the ZFS page size. So the first 16 kilobytes are information, and the next 28 minus 16, 6, 106, that's probably not right, but whatever. Over 100 kilobytes, 16, thank you. Over 100 kilobytes are wasted for every disk page. I'm not going to bore you with the story of how I found it. It was fascinating how we found this problem once. But I'm not going to go into it because it's too long, and we've got a lot to cover. InnoDB buffer pool pages total, that's the number of total pages in your buffer pool. If your buffer pool size divided by your page size does not equal your buffer pool pages total, then you probably did your math wrong. Buffer pool pages data is the amount of data and indexes. Buffer pool pages free is the number of free pages. Buffer pool pages MISC has some kind of metadata, but it also has the adaptive hash that we were talking about before. They're used for a little bit of admin overhead, like the row locks. They're also used for that adaptive hash. So for example, in here, you can see that they're not using very much for the adaptive hash index. If you see that your InnoDB queries are taking a lot longer than you thought, and this is kind of a large percentage, you might think about turning the InnoDB adaptive hash index off. Dirty pages. It's not really dirty. It just means it's written to. A dirty page means it's been written to. And I was talking about this before. I think I said that the max dirty pages percent by default is 95. It's actually 90. What this means is after this percent is reached, you're going to actually wait while those pages that have been written to are actually flushed to disk. InnoDB buffer pool wait free is a counter. It's a status variable because it's capitalized. It's a counter for the number of times the buffer pool had to wait for these pages to be freed by cleanup. So basically, how many times did we hit this? Okay, this is 0. So if we want to flush to disk more often, we could lower this. Usually you don't want to flush to disk more often because disk I/O is, expensive. So 90% seems like a lot. Like, would you wait for 90% of your clothes to get dirty before you did laundry? Probably not. Would you, right? Would you wait for 90% of your gas tank to be empty before you got gas? It's a little risky, right? Because you wouldn't want to have to wait, i.e. stall on the highway, while you're filling up your gas. That's a really bad analogy. The laundry one's better, but you get like 2 weeks of clothes or a week of clothes, and you do your laundry, right? More if you have children, probably because they actually can get to 90% of their clothes dirty in about 3 days. InnoDB, I told you my jokes. I'm not even doing this on purpose. My jokes just get worse, I guess, maybe as I get tired. So InnoDB buffer pool pages dirty. I love these short names that they have. It means how many pages are actually dirty. Here it was 9. Okay, there were 9 dirty pages and 524,000 total pages, which means they weren't really doing a lot of writes. It's pretty much what that means. This dirty pages is included in the InnoDB buffer pool pages data. So if you want to say, well, does this include, like, is the total page, is the data pages 5 plus this 46,905 plus the dirty pages? No, it's already included. So this includes the clean pages that have not been written to, and the dirty pages, which have had data changed. Flush and sync. This is InnoDB specific. By the way, anyone who doesn't use InnoDB, we're doing all InnoDB for the rest. So if you don't use InnoDB and never plan to and don't want to learn about this, take a nap, go outside, enjoy the rain, whatever you want. I won't be offended if you leave. Flush sync, InnoDB buffer pool pages flushed. It's the count of the number of times you've flushed pages. Data fsync, the count of the number of times you've done an fsync. Data pending fsync, how many times you've called the fsync but it hasn't been done yet. So usually it's 0. I don't think I've seen this really be very high. And I've rarely even seen it be like 1. InnoDB row locks, these are all status variables. They'll be in capital I. So how many times have you had to wait for a row lock? How many current threads are waiting for a row lock? How much total time you've waited for row locks? If this is large, okay, this is what, 31 seconds over, weeks, 31 seconds over however many queries we did. That was in the first session, and I don't think I had a number. The average lock time was 117 milliseconds. The maximum one was 4.6 seconds, basically, was the maximum time, but that probably only happened once. So again, if all of these are high, like lock waits is high, this is 269, that's nothing. So I think 31,637 divided by 269 is probably 117 because that's the average. If these are high, then you want to look and see why are there so many row locks going on. That may be why you would want to change, where is it, auto ink lock mode, if those things are really high. Because there's not, is there a timeout for that? If there is, we'll get to it. I don't know if there's a way that you can really change that. But it's good to know if there's a lot going on, because that can be indicative of a problem. So reads, this is pretty easy. InnoDB, how many times has there been a request to read from the InnoDB buffer pool? How many buffer pool reads? What does that mean? It means read buffer pool could not do and single page read. These are like my notes to myself. It could not actually do a read from a buffer pool, and it had to do a single page read. So it had to go to disk. So it's a weird, it's a weird variable because what it really means is it didn't read the buffer pool. So if this is high and this rate is increasing at a high rate, then what it means is you probably need a bigger ENODB buffer pool. But don't we all? ENODB data reads. So this is how many times you have. Oh, is that data reads from disk? I may have messed up my my notes here. I need to get that right for you guys. Buffer pool reads. Buffer pool reads. See why these are bookmarked system variables? Yeah, number of logical reads that ENODB could not satisfy from buffer pools and had to read directly from disk. So what's data reads? Okay, I didn't get this wrong. The total number of data reads. Oh, okay. So you can find out your hit or miss ratio. Basically, how many times did I have to do a single page read versus how many times have I done a read, period. So most of these are actually, this is probably pretty bad. This might have been, where basically it just cached everything and that's it. Right, because a lot of the reads are done from disk. Or it could be indicative of a problem, but there are 8 gigs in the ENODB buffer pool size, so it depends on the data set. If they have 100 gigs of data that keeps going in and out of the thing, then they would really want to increase their size of their data, or maybe partition off some to a different location.
How does that relate to the 1,360,000?
So the question is, how does it relate to the ENODB buffer pool read requests? There's a difference between a request for a read and a data read. So you can actually so you might request to read 3 different rows, that's 3 different requests, whereas that might be one actual read, right, of the buffer pool or the data. Does that make sense? Okay. Well, let's see what the manual has to say. Maybe they'll say it in a way that makes more sense. Buffer pool read requests. Number of logical read requests ENODB has done. So yeah, it's not very helpful. But basically, it's ENODB data read, so it's the total amount of data read. ENODB pages read, total amount of pages read. ENODB rows read. Right, so you can see the ENODB number of rows read is 2 billion. This is 1 billion. So you can say, okay, a request could be for like maybe on average about 2 reads, which kind of makes sense. You might read and then read the next, you might read the next record ahead of time just to see. So you might request this one and the next gap, the next key locking. ENODB writes, so similar things, number of write requests versus data writes. So again, there's a big discrepancy here. So you might have a request to write, but you only write a certain number of times. And this actually helps, it's like batching, right? It's batching your writes a little bit. It's ENODB doing its own thing. And then obviously pending writes, if you're pending write, that would be a bad thing. Amount of ENODB data written. So 153 gigabytes. So I'm looking at the server and I'm like, wow, your ENODB pages, like you always read from disk, but you wrote 153 gigabytes. Okay? You read 695.47 megabytes. Okay? So this is being basically used, this is pretty much a write mostly database. So it's not really a quandary that like, hey, how come you're always reading your pages from disk? It's because you're not really doing a lot of reads. And this is something that you can divide by uptime and say, okay, how many data writes versus data read per second versus reads per second. So you have 27,000 buffer pool reads. You have 12 million data writes. So number of pages written, or 4 million pages written versus 44,000 pages read. So you're just not reading a lot of data. So it's not, you only probably are reading it once, and so it's coming to cache and never really being used because you're never reading it again. You're just writing to it.
So why use ENODB here?
So why use ENODB here? That's a good question. They just are. They might need it for if you're doing a lot of writes, then if they're doing a lot of updates or deletes, they can't necessarily have a locking for updates and deletes. Or it could just be that they should be using ENODB, they should be using MySQL, and they just haven't run into any performance problems. So it could be either of the two. My guess is, knowing this client, that it's the updates and deletes.
No, but here I do not understand. I wasn't here earlier, but my understanding is a thing that when you have database, why you want to use InnoDB?
So you said your understanding is the database, right?
Yeah.
But why? So
because the transaction is simpler to develop.
Because the transaction is simpler to develop. Is that because of the locking though? So this is the question. People say use InnoDB, but like they just say, well, it's better. There's less locking, right? But there's more overhead. But there's more overhead too because it will batch things a lot of times, right? You do a lot of writes and it changes the dirty pages of memory and then eventually it writes to the disk, right? So it can, when it writes to the disk, it can write like a whole page which might have a lot of changes, right? So that helps a little bit. So really the question is, well, what's your usage of it? Okay, a log inserts once and it never updates it, it never deletes it, it almost never reads it, right? So why would you use InnoDB for? You don't need it to stay in the cache, right? Because once you insert into, you can't insert into InnoDB, you can't insert directly to the disk. You have to insert it in the cache, right? When you insert it, it goes into the cache, the buffer pool, and then eventually gets written to disk. So that's really good because as soon as you write it, it's right there in memory. So now a lot of, say, a web application is you want InnoDB because the second I write, hey, Shri is a new user, what's the next thing I'm going to do after I create an account? I'm probably going to log in. So I'm going to need that. I'm going to want that information anyway. If I set my profile settings, it's probably because I want to go display something in that setting. So that's usually really good. But because you've got this mixed thing of reading and writing and you don't want the locking. If you're doing write, well, if you're doing a lot of updates, my ISIM has table locking, or a lot of deletes, my ISIM has table level locking, and you're going to run into contention. So it's only for insert writes. It's only for a lot of inserts. And that's why, as much as I totally agree that for most cases InnoDB is good, you can actually run into a lot of problems where because a lot of people, especially nowadays with, they're trying to do data mining and all that stuff, they're like, just log everything. Just whenever somebody looks at something, whenever they scroll, whenever they mouse over, just put something into the database. Whenever they, whenever they step away from their computer, right, things you can't even do, just write it to the database and we'll figure out what to do later. For some people, if they can't convert to MyISIM or they can't, because maybe the table's huge and won't lock, we're like, hey, use a black hole table and do your reporting on the slave, right? Because you don't care if it never gets to the master. You never read from the master anyway. Not that table, not the log table. Just do that and then, figure it out on your slave and, do some ETL into a real data warehouse and then mine it that way. And that's one of the good things. I mean, we don't think about it, but it's one of the things that's good about MySQL. As much as we're complaining about this is global, so don't change it, because it's for every table, the storage engine is per table, which is kind of nice. So you can have, imagine if the storage engine was, if you had to pick InnoDB for everything or MySQL for everything, right? You'd end up in the quandary most people find themselves in because nobody tells them why, right? They're just like, oh, I have to use InnoDB because it's better, and they do, and then sometimes they'll end up in these problems.
Do any other tables have a referential integrity?
So the question is, do any of the other tables have the referential integrity, like the foreign key checking? InnoDB does. You're saying other than InnoDB. Not in production, like Falcon is supposed to. I think MariaDB is working on it. And I think MySQL is also working on it to put it in the store, in the MySQL, like above the storage engine layer. So all storage engines would have it. But I think that's pretty much your only bet for that. The other thing though is, are you actually, what do you do with an error, right? If you have foreign key checking, if you know DB, and your application tries to insert something and it fails, what happens? Does it just get rid of an error log somewhere? Or does it actually try the transaction?
In my case, it aborts. It also prevents somebody from going to PHP-MyAdmin, sticking dates in that violates referential.
Right. So the comment is the application won't have that problem because, and if it does, it would just abort. But it also prevents, somebody manually going in and, adding in that data that doesn't have any referential integrity. And honestly, the answer to that is kind of the answer that it was before there was foreign key checking, which is it should be done in the application anyway. So yeah, should is a hard word. It should be done in the application and nobody should be adding that data anyway. But you could say, well, I need referential integrity. Well, why? Shouldn't you? You need to be checking it in the database, in the application anyway, because if you do insert something and it doesn't meet the foreign key checks, you're going to get an error anyway. So what do you do with that? You're going to have to then insert it or whatever. So it's best to check that the parent records exists anyway first. It's a weak answer, but yeah. So if you do need foreign key checking right now, then yes, you have to use InnoDB. So rows written. So again, how many InnoDB rows were inserted? How many rows were deleted? How many rows were updated? So here's your question: wouldn't it be better to just use that? No, because they only have 32,000 inserts. They're mostly doing updates and a lot of deletes, but not a lot of, not as many inserts. So if they were doing like 100% inserts or mostly inserts, we would say, oh, you're doing all this stuff, you should use MySQL. InnoDB log basics. So InnoDB log file size. So the InnoDB logs are where the, I want to get this right, there's an undo buffer and a redo buffer. I'm trying to think in my brain. The undo buffer, is the rollback, is what you would roll back. So the InnoDB log file has the redo buffer. And this is basically for ACID compliance so that your transactions are durable. So what happens is, when a transaction commits, first it writes to the InnoDB log that it committed, then it goes and changes the data. Now, the reason this works is because if you have a crash, after it writes to the log file, but before it changes the data, crash recovery will look at this log file and look at the redo log, hence why it's called the redo log, because if it crashes, you have to redo this step, right? And it will go ahead and do that. And InnoDB will go ahead and, once it actually writes to disk, it will say, okay, we don't need to redo this part of the log anymore. So that's what the InnoDB log files are good. They're really, really very useful. If you end up doing a clean shutdown or whatever, you probably don't need the InnoDB logs because there's nothing to redo because you've had a nice clean shutdown and there's no problems. InnoDB log files in group. This particular client had 3, by default it's 1. InnoDB mirrored log groups, so if you're really, really concerned about having, double redundant everything, you can have mirrored log groups. You have more than 1, so 1 is the default, and that just means have one set of log files. I don't think I've ever encountered anyone that has more than 1. An InnoDB log group home directory, by the default, it's going to be the, where the InnoDB, the data directory, InnoDB data directory, all that kind of stuff. Some people change this, if you want all your logs together. But really, the InnoDB log file isn't really a log in the sense of like a binary log is, well, you want that binary log separate from your data because, that's really kind of a backup log. This is really kind of it's part of the data, right? Because if the server crashes, you need that to be able to reconstruct the data that you had at the time the server crashed. So you usually want this on the same partitions as the disks as the data because it basically is, what do I need to do to my files to get back to where I was? InnoDB logs, so you have the log buffer size. So there's the log file itself, which is the file on disk, and then there's a log buffer. So InnoDB actually writes to the log buffer, and then the log buffer flushes to disk. We talked about InnoDB flush transaction at log commit. That was this redo buffer, right? So you can set it to 1, which means that every commit, it not only writes to the log, but it flushes it to the disk, or you could set it to 0, which writes the log and flushes to disk every second, or you could set it to 2, which when you do a write, when you do a commit, it writes to the log buffer on commit, and if you do 100 per second, it will commit 100 times and write to the cache, the log buffer 100 times, and then write once to the disk, because it's once per second. So InnoDB log weights, so this would be bad. If you have InnoDB log weights, you want to increase your log buffer size. InnoDB OS log fsyncs, how many fsyncs that you've done and how many pending fsyncs. InnoDB log writes, so again here's the same write requests, the number of writes, the number of pending writes, and how much of the InnoDB log written to the operating system, 14.42 gigabytes over the life of this MySQL instance that has been up for however long it's been up. Other InnoDB variables are InnoDB additional memory pool size. This is the additional memory for things like the data dictionary. If this is too small, you'll get a warning in the error log, and more memory is going to be allocated to the operating system, by the operating system, excuse me. So if this is too small, it's not like it's a limit. It's just you're going to get an error that says, hey, my additional memory pool is too small, so I'm just grabbing some more memory, okay? So it's not a big deal. It's not going to crash your server. It's not going to stop anything from working. You'll still actually be able to allocate additional memory. You will see warnings in your error log, so it will be very, very obvious when you need to increase this. But even if you don't, it's not too much of a big deal. InnoDB open files. These are file descriptors for the .ibd files. This does not affect the table open cache, because the table open cache I believe is for .frm only, not for the .ibd files. And this variable is independent of other open file limits. And I don't know why it might be like a InnoDB kernel open thing versus an actual file open thing. InnoDB thread sleep delay, how long in microseconds. So this was set to 10,000. I'm like, that can't be seconds. So I looked up, and in fact, this is like the one time value that's in microseconds. And then I had to figure out microseconds. Like, what's a micro? What's the prefix? And how do I divide? So there you go. How long a thread waits before joining that InnoDB queue. That's, when we talk about the queues and the spin weights and the tickets. It waits 0.01 seconds. So, let's get into even more advanced InnoDB variables. InnoDB flush method. So, by default, fsync uses, InnoDB will use fsync. This is, I think it's on Linux and Windows, but most of us aren't using Windows, so there you go. By default, uses fsync to flush the data and the logs. You can actually set the InnoDB flush method to odesync, which uses osync to open and flush logs, and fsync for the data files. So by default, it uses fsync for both data and logs. You could say odesync for opening and flushing logs with sync, and fsync for data. And you can also say odirect to open the data files with odirect, and fsync to flush. So really, this is one of those, if you know all about all those different methods, because I don't actually really know about the operating system methods and why would you want to use osync as opposed to fsync, I have no idea. Or direct IO on Solaris, actually. If you are like, oh, why are we using fsync? Why don't we use this better method? Here's where you can set that. It's only and if I read my notes, this variable is only relevant for Unix. On Windows, the flush method is always async, unbuffered, and cannot be changed. The InnoDB max purge lag. If the number of transactions that update or delete is greater than this, which is 0, and it's 0 by default, so if you have at least one update or delete statement, then delay a while before proceeding. Okay? 0 means no delay ever. Right, so 0 means don't ever delay, but if you could say, okay, if it has one, if it's more than 1, then delay, if it's more than 10, then delay, but if it's 0, don't delay at all. No, I don't know how often it delays. It might actually be this thread sleep delay, I'm not sure. Again, this is one of those things where it's a little anti-intuitive, but if you think of the 4 people at a time, shouting at the person at the high-up desk, sometimes it's a little better to sleep a little bit and give everyone, let everyone wait just a little bit. If you came to a stoplight and everybody on the other side went and you had to wait for 10 minutes, wouldn't it be better to make them wait a minute and you wait a minute? How a stoplight really works, right? You wait a minute and then a bunch of people go, and then they wait a minute, and then they go, and then you wait a minute and then they go. So it's more of a kind of interweaving, and it's better for overall throughput to not have everyone come at you at once. So, InnoDB status for performance. We're doing really awesome on time, aren't we? 4:20. This is awesome because we're getting now into, after this one, we basically start with the Percona slides, and those are a lot more complicated. And so, I think we have plenty of time for this stuff. InnoDB buffer pool read-ahead R&D. This is the number of random read-aheads for when basically you're scanning a large part of the table, but in random order. InnoDB buffer pool read-ahead SEQ is sequential read-aheads for when you're doing a sequential full table scan. And high rates of both of these are bad, right? So a sequential scan is actually a little better than a random scan because, again, well, if you're talking about disk seeking, right? If you have an SSD disk where everything's in, well, it's buffer pool, so it's all random, so scratch that. Basically, it's, if it's in memory, random accesses are, the same cost as sequential, you don't get any benefit. If you have a lot of these though, it's doing table scans, large chunks of the table scanning, either full table scan or large chunks. So it's probably not using optimal indexes. So a large number of these usually aren't good, but unfortunately there's no setting to set to make it better. It's just kind of optimize your queries. So, are there any questions about InnoDB? Or anything else that we've gone over today, throughout the whole day today, before we move on to the Percona patches? Is there a way to know how much of the database is loaded into the buffer pool? Yes, actually, back in the buffer pool section. So you have the buffer pool size, which is 8 gigabytes. You have the total pages, and then the total pages free. So you can subtract to get the total pages that are used, and then multiply by the page size to get how much data is used. So that's kind of your active working set. But that's data and indexes, and it's hard to know exactly how much data indexes there are anyway, because InnoDB statistics are approximate. So let's say you know you've loaded some of 2 different tables. You don't know if that, how much of each table it is, because you can't just look at one table and say, well, that's a certain size, so maybe it loaded all of it, because you don't know the exact size. So anything else? I mean, Barrett, you just walked in. Would you like to do the rest of this presentation, which is on the Percona patch extensions?
I'll save my voice for tomorrow.
Okay. If I say anything wrong, feel free to correct me, and I will say that we have a bunch of clients using the Percona patch set, which is great. They're using Percona log. I'm not quite sure how different that is from XtraDB. But I know that when you do a show version, sometimes, like if you actually download XtraDB, the version will say XtraDB. The versions we have say Percona-log, which means the Percona patch set as opposed to XtraDB. Now, I will say that for the clients that we installed this on, performance got a lot better right away, and honestly, we haven't really played with much of the stuff that I'm going to tell you about. So, I'm going to refer to manuals even more than I have been, because a lot of these are new, they're kind of new to me, and there are a lot of, there's a lot of explanations where I'm like, I'm not really sure, because all I know is what I read on the Percona site, so Baron certainly can help us out if he knows as well. Is anyone here actually using the Percona patch set? Anyone? Yeah? Have you tweaked any of the variables, or?
No.
No, not yet? Okay. That's super. Pardon me, I'm just getting my actual notes out, because I did these slides after I printed these out, like last week. So, at any rate, so Percona has both XtraDB and the Percona build. Most of these variables are in both of them, if not all of them. Here are my notes. It's actually really great. Like I said, we've actually installed the Percona patch set on clients, and they've just gotten a much better improvement in performance already that we haven't even really needed to play with some of these. So specifically, how do I know what the extensions are? Well, I looked at one of our clients that was running Percona log 5136, and I looked at the variables that were different from a client running 5136 on regular MySQL, and that's how I figured out which variables were different and which ones had been added. Then I went to the Percona wiki pages and looked at the information there, and so I might have added 1 or 2 as well. So these slides are current up to that version. There may have been some added variables. The other thing is I'm only doing the output of show global variable, show global status. I do mention a few of the new information schema tables and a few of the new is just information schema tables, and some of the things that are new in show engine InnoDB status, but I don't have everything in there. Someone during the 30-minute break was talking about some of the information schema tables that Percona added, and I'm like, really? I didn't even know those were there, because again, we've had so much better performance that we haven't even had to bother looking at some of those statistics, but they are good. So this is not a complete differential set of everything that's in the Percona patches. It's just what you can see in the output of the variables, since this is just limited to the variables. Otherwise, it's already 4:26. I could go another 4 hours on all the different additions Percona's made, because they've really done a bang-up job, really good job of doing this. So the Percona build and MySQL, these are relevant for the standard build and the InnoDB plugin build. I said before, and I think I said it in the previous tutorial, not this one, that I'm not actually going into any of the InnoDB plugin variables that MySQL have, only because I just don't have the time to do it in this 3 hours that we did here. And so basically, this URL down here, which again you can get off the slides, is all of the variables alphabetically that they have added. So that's also where I, once I found that documentation, which actually Morgan Talker from Corona helped me find, I was all golden and I could, write the rest of these slides. So I/O extensions. So InnoDB read I/O threads is the number of background threads for read prefetching requests. The default is 1. So actually, one thing I wanted to say is that Percona's actually done a really good job where they've made all of these knobs that you can tweak. But what they've done is they set the default to the same things that regular InnoDB is, right? So the default is that there's one prefetch thread. That's the default for MySQL. There's no way to change it in regular MySQL. If you have the Percona patch set, you can actually change it. You can. The range is from 1 to 64, so you have up to 64 prefetching threads. InnoDB write I/O threads, which is the number of background I/O threads for writing dirty pages from the buffer pool. The default again is 1. The range again is 1 to 64. This is actually something you can see in show engine InnoDB status. And let me do that here. This is not a Percona build. Super password. Show engine InnoDB status. Now, here we go. Dirty pages from the buffer pool. So here, you see here, mark. So here under File I/O, you see that this has, now Percona doesn't make a Windows build, by the way, which is fine, right? You don't know Windows build? I don't think I've ever checked, but.
Yeah, I don't think we do.
Yeah, so, I mean, if you're using Windows as a production MySQL database performance, you probably aren't at the level of performance where you need the Percona patch set. So you can see here we've got 4 I/O threads. One is for the insert buffer, one is for the log, one is for the read, and one is for the write. If you want more of these, increase those variables. Increase these 2 variables. I don't know how to do that. InnoDB I/O capacity is, I'm looking at this, that's why. I'll make this one. So the InnoDB I/O capacity is the number of disk I/O operations that InnoDB assumes the server can perform per second. Okay? The patch actually adjusts InnoDB's behavior to actually use more I/O resources when it's told they're available. The default is actually 100, which is again how regular InnoDB works. So by default, InnoDB says, yeah, server can do 100 operations per second, which is not necessarily what your thing can actually do. Right? So you can set it anywhere from 100 to 999,999,999. Huh? A RAM disk, yeah. InnoDB use purge thread, the default is 0 through the InnoDB plugin version 1.05, and it's 1 starting 1.06. The range is from 0 to 64. So the default is 0, meaning also regular InnoDB works that way. There's no other information that I could find in the quick search that I did. I could probably search more, but I didn't have much internet when I was making these slides. But basically, whether or not you're using the purge thread, it's probably faster, better, more performant if you do. But again, if you do use the patch set, I would say look at that and see if it's something that you would need. So more I/O extensions. iBuff, by the way, is the insert buffer. Okay? So whenever you see iBuff, it means, hey, it's the insert buffer. So InnoDB iBuff accelerate, if the InnoDB I/O capacity that you set back here, I don't know why I do that. The InnoDB I/O capacity that you set back here, remember, this was the, what the capacity of operations per second is. If it's not enough to tune that insert, to tune also the insert buffer, you can actually set a specific kind of I/O capacity for the insert buffer itself. So, you might say, well, I want to assume that it can do, for I/O, that it can do, 200 threads per second, but specifically for inserts, I want to assume that it can do 300 operations per second. So you can actually fine-tune it that way if the InnoDB IO capacity is not enough to help the insert buffer. There's also InnoDB iBuff active contract. Defaults, again, in InnoDB plugin up to 1.05, the default is 0, and 1.06 plus, the default is 1. 0 means that when you're using the insert buffer, you don't need to actually make it smaller, contract it. It's not, did I say contract? I meant contract. You don't need to contract the insert buffer until you've reached the maximum size, which is the next parameter. And that's the default behavior. And a value of 1 means actively contract it. Basically, whenever you can, whenever possible, InnoDB will do it. That action is actually asynchronous in InnoDB, so it's not like after every transaction, contract the insert buffer. That's not how it works. It's just an asynchronous thing. The maximum InnoDB iBuffer insert buffer max size. I'm just going to read here because it's the best description is that the default value of this is half the size of the InnoDB buffer pool. The range, like what you can set this to, is anything less than half of your buffer pool. Starting with 0. 0 is very small, not like unlimited, and very small values aren't really good for performance. So if you use very fast storage, so SSDs or whatnot, then small values, which they say like several megabytes, not like 1, right? So smaller values, like a few megabytes, can actually show better performance. So let's see. If the storage doesn't have RAM level, speed, or response, then the performance will drop if you lower it. So this is again one of these things that if you really know what you're doing, it's probably more for the flash-based, the RAM-based disks than for anything else. If you need to change it. Even more I/O extensions. Can you tell that file I/O is one of the biggest problems in MySQL, or even just writing in general? InnoDB enable unsafe root commit. This is actually there for a bug that was fixed in InnoDB plugin 1.0.6. Basically, the default is 0, so it's not needed after XtraDB 1.06. A value of 1 will force a root commit, even if with binlog. That's not proper English. If 1 is set, InnoDB transaction log will. I know what it is. Basically, unsafe root commit means that the InnoDB transaction log, right, the redo log, and the binary log may not be in the same order. So they might have actually been changed in a different version, in a different order in InnoDB than in replication, which is, again, unsafe. So it's not necessarily recommended for that reason. I wasn't able to find which bug was fixed by it, but again, if the only reason that you need to turn this off or on, because the only reason you need to be unsafe by turning it on is if you're suffering from this particular bug. Flush neighbor pages. So if a dirty page is flushed, you also flush a neighbor page. The theory is if you've updated data in here, you might have updated it there too. So why don't you just flush them at the same time? Since you're already at this point in disk, if you're flushing this page here, why not flush this page here too? Because your disk head is right there. By default, it's 1, which is yes. By default, if you're flushing a page, you should flush this neighbor too. But 0 is better for disks that don't do that seeking, right? So if you are seeking, you have a disk head that's seeking, it's better to say, okay, I'm here now, let me do everything that's in this area before I move on to over there, because you have delays in it. If you have a RAM disk, like an SSD, there's no need to do that, because if you're here or here, if going from here to here is the same as going from here to here. Not so much so with as I call them, spinny disks that spin and you need seeking. Okay, so that's actually better for SSDs. You can kind of see where Percona has done a lot of optimizations, right? They obviously have clients that have a lot of SSDs, and a lot of this is another reason why I like to tell you why. Because I could say, hey, you should definitely always put your logs on a different partition, on a different disk, spinny disk, than putting your data. And that only works if you know why, right? That only works because you know that it's the spinny disks and it's the heads that are moving, right? That goes out the window when you start talking about SSDs. So it's one of the reasons that I like to tell you guys why, because I can tell you, hey, this is when you would do flush neighbor pages, this is when it's good to have it on, this is when it's good to have it off, so that you can make the decision, you know, and you know, when your company gets a certain kind of disk, whether it's SSD or spinning disk, you can make the right decision for your company. As opposed to, well, 99% of the people, or maybe 90 at this point, 90% of the people are still using spinning disks, so I'm just going to say, use this and not tell you why. It takes longer to tell you why. But now you won't get mad at me when you're like, Sherry, you said to use spinning, you said to use different partitions, and it makes everything worse. What's the problem? Well, the problem is you're using, you know, that I didn't tell you why. So InnoDB read ahead, this parameter here, controls native read ahead behavior of InnoDB by default. Okay, so let me explain. The default is both, which doesn't help you because you don't know what both is. None means you disable read ahead. Random means you enable read ahead for random access only. And linear means that you enable read ahead for sequential access only. Both means you enable read ahead for both linear and sequential. No, linear and random. So why might you not want to do that? Well, again, if you have an SSD, you might want to do both. If you have spinny disks, you might want to turn off read ahead for random access, right? Because you don't want to do read aheads on random access. Your disk is going to be spinning, unless of course you're talking about the buffer pool. So, but by default, InnoDB does both by default. So. They do say, though, that the read-ahead for random access, so if you just have random, is removed from the plugin 1.05, removed from InnoDB plugin 1.05, so in ExtraDB 1.05 and up, it just ignores the random part of it, because it doesn't exist. Oh, non-random, linear, both. Checkpointing. InnoDB adaptive checkpoint. So adaptive checkpointing changes when the blocks are flushed to disk instead of flushing when you reach max 30 pages %. Okay, so instead of having to wait till 90% or whatever you set that to be, and then flushing, this will do an adaptive checkpoint. The default value is none. There is no adaptive checkpoint. You only flush to disk when you have a certain number of percentage of data or dirty pages, which is how it's really nice that they just make it work and make it. You just install it and it works the same way that InnoDB worked before with some performance improvements. And then if you want to tweak these knobs, you can. So there's also reflex, which says if there's a block that is half the maximum age, and I'll talk about what the maximum age is, you start weak flushing of the blocks. I'll talk about that in a second. If a block is 3/4 of the maximum age, so the maximum, if you have a maximum age, and if something gets to half of that, you start weak flushing it. If it gets to 3/4 of that, you start strongly flushing it. And the strength is based on the InnoDB I/O capacity. So if you do use reflex, you need to adjust InnoDB I/O capacity to deal with the whole weak and strong kind of thing, because the strength of that is determined by the InnoDB I/O capacity. There's reflex, there's also estimate, which doesn't use InnoDB I/O capacity, it just kind of estimates it automatically. Basically, if the oldest block is older than half the maximum age capacity, then it will flush a certain number of blocks every second, and a certain number of blocks is determined by basically a bunch of factors. It is completely independent from InnoDB I/O capacity, so you don't need to do the tweaking that you need to do with reflex, but the whole feature of estimate itself is experimental. InnoDB checkpoint age target, by default it's 0, which disables the feature. And basically, this is how you control the max checkpoint age. And basically, what does it say? Max checkpoint age ASIN can be controlled by its value. It is not needed to shrink the InnoDB log file size to tune recovery time. So basically, this is how you affect what that age is. And the log section of show engine InnoDB status will actually show you max checkpoint age. I can't show you here because I'm not running the Recon server on this Windows machine. I can't run like 7 different servers for the Windows machine. So the log section, actually I'll show you what the log section looks like, and then I'll tell you what else it has. So the log section, so you just have sequence number flushed up to last checkpoint at pending log writes. 8 log hour was done, X number of logs per second. What these patches also add is they add max checkpoint age, the modified age, and the checkpoint age. So you get the max one, what the current, like the oldest one is. So are you at that half or more of the max yet? You can see that there. So, getting back here, how are we doing on time? We got 15 minutes, a little more than that. Show engine ENODB status. So this is a buffer pool memory. So basically they've added everything, the plus here they've added. This is taken directly from the website. And basically they've added extended information of the internal hash table size in bytes in the buffer pool and memory section. It also adds buffer pool size in the bytes information. So you get the buffer pool size in bytes as opposed to, I think this is pages. And then you also get how much, right? So we know that the ENODB buffer pages pool MISC. It's the number of pages that are used for some metadata and for the adaptive hash index. This actually breaks out how much of those pool pages MISC are used for the adaptive hash index, how many are used for page hashes, how many are used for the dictionary cache, how much is used for file system, lock system, recovery system, threads. So this is actually really, really nice to know. You get that breakout because again, like let's say you want to say, well, is the adaptive hash working for me or not? You know, you don't know if the ENODB pages pool MISC. Is that all dictionary cache or is it all adaptive hash? How much is how much? So they've actually added that in, which is really, really, really nice to have. It's one of these things that you probably don't need it, but if you do need it, oh, it's nice to have. ENODB show verbose locks. I don't know why. ENODB show locks held actually shows the number of locks held to print for each ENODB transaction and show ENODB status. So if you show ENODB status, you have the transactions will say the number of locks held. This is it. There's also show verbose locks, and that's whether or not to show the records that are locked and show ENODB status. So both of these, turning both of these on gets you a lot more information, which is pretty cool. ENODB stats method here. This is similar to the MyISM stats method. Remember we had nulls equal, nulls unequal, or nulls ignored. But ENODB doesn't really have different pattern of statistics. So even though you need to change this dynamically, you do need to recalculate the statistics in order to change the method for the table. So for MyISM, you don't need to recalculate the statistics. It's just new ones that will be done, but you probably want to recalculate it because the whole point of changing the thing is so that your index is getting done. Here you have to. You cannot change it without actually doing it. And I don't know what the implication of that is on locking and whatnot. Like I don't know if you change this variable and restart, you know, or if you do it dynamically, if all of a sudden all your ENODB tables are locked until the index is rebuilt. I don't really know how that works. So ENODB stats update need locks, which is by default it's 1. If you meet contention of the dictionary operation lock, you can set this to 0 to reduce contention, but it actually disables in show table status 15 minutes. In show table status, if you actually do disable stats update need locks, you don't get the data free in show table status. I don't think many people use data free in show table status. Most people just have either auto extend on their ID data files or they just use ENODB file table. So ENODB stats auto update, the default is 1. ENODB updates each index statistics automatically. Setting this off to 0 can stop these automatic recalculations of statistics except for when you first open the table and analyze table. So this does reduce overhead a little bit, but your statistics won't be accurate because if you do a lot of inserts, you're not actually going to get the new statistics metadata until you do an analyze table. Now again, that can be really good if you're doing a batch load or something, right? It's this, there is the alter table, disable keys, enable keys. This does a similar thing, but you don't need to disable the keys and then re-enable them or whatever. You just do it per for that session globally. So I did say that I wasn't going to talk too much about information schema, but this kind of relates to some of the things we've just been talking about. And I do not have examples for you, so I think that in the interest of time, I'm just not going to go over them because it's going to be really weird to explain to you an ENODB an information schema table when it's just a lot easier to look and see what the table has in it. And I can tell you what it has in it. It has the index, the ENODB table stats table has the table name, the estimated number of rows, the clustered index size in the number of pages, the other size for non-primary keys in the number of pages, number of pages modified, which is an internal counter to basically judge whether or not you should recalculate the statistics. And then ENODB index stats has index information of the dictionary cached. And so it has table name, index name, how many fields are the index key has, how many rows per key value. So remember we were talking about, like, well, if you have a key value of null, then will you have 0 groups, right? If null's ignored, you'll have 0 groups. If it's null's unequal, you'll have 1 group for every null value, or if it's null's equal, you'll have 1 group for all the null values. So that's that kind of thing. I mean, if you have different values too, you'll have different rows for that. And then the index size, and then the number of leaf pages in the index. So that's what's in there. Again, pretty useful if you need it. Hopefully you will never need it. Recovery, ENODB fast recovery. It's basically a hack not to. It's a hack not to sort stuff when you're doing fast recovery, and ENODB recovery stats are on by default. And again, it's just, oh, here's the recovery stats. If it's on, you see this. So recovery time, you see, okay, 18 seconds. This actually comes into the error log, I believe, when the recovery is happening. So it tells you how much time that you had recovery. It took 1 turn, 18 seconds. Here's the requested pages, here's the read pages, here's the written pages, here's the dirty blocks. So basically, I had to change some data, so I had to request the pages, I had to, then read them, and then I wrote out this many pages, and then, which was this many dirty blocks, and, this gives you, even more data again. And recovery process stats. How many pages were checked by the double write buffer? 128. How many pages were overwritten from the double write buffer? 0. That's pretty good. That means even though you crashed, right, you didn't have to do anything to fix the information. It was fine as it was. Recovered pages by IO thread. Okay, that's good that we recovered those pages. Recovered pages by main thread. We didn't have anything to do. How many log records to apply? Okay. Oh, so we did have to do something. We just didn't have to overwrite from the double write buffer. We did have to apply some log records, actually a bunch of log records. And so, this is basically what's the oldest page time, what's the newest page time, the pages which are already new enough, 93 of them. So again, this could be something very, very useful if you're having problems with recovery or you're trying to figure out what happened in ENODB recovery. I hope that you will never need this kind of stuff, because if you do, you're knee-deep in, oh crap. You're knee-deep in, oh crap, this isn't working. Which, again, that's, what Percona does when they patch stuff. Actually, it's like the one thing that I don't do, that my company doesn't do, actually, is we don't patch stuff. We leave it to, we have an enterprise support, platinum, whatever stuff. So we, when we get to that far, we're like, can you just give us a patch, please? And, Percona does that too. They just don't ask MySQL, they do it themselves. So other extensions, ENODB thread concurrency timer based. There is no documentation on this. I think there's probably a blog post that I missed somewhere, but again, I didn't have a lot of time to read all the blog posts. I just was reading the documentation. So there you go. I am the kind of person who reads documentation, like some people read the encyclopedia or whatever. I don't know. I'm a freak. Have I mentioned I wrote a book? I had to read all that too, so maybe it's not too crazy. ENODB relaxed table creation, don't know much about that. All the manual says the default is 0 and the values are 0 or 1. And it's a global variable and dynamic. I'm guessing it has something to do with having fewer restrictions on table creation, which might make it say, faster, but might also make it less safe. I don't know. Again, probably a blog post I missed somewhere. Information schema added, so you have this InnoDB extra R segments, so you have a new information schema for InnoDB RSeg. And basically RSeg is a rollback segment. So rollback is in your undo buffer. So when you start a transaction and you do a couple of queries, right, you have some things that you might need to undo if you roll back. That's called the undo buffer. And that's stored in the R segments. Is, what would if I roll back, what would I need to do? Okay, I need to undo that. And the fields in the table are the segment ID, the space ID, which is the space where that rollback segment is placed, the compressed page size in bytes, if it's compressed, otherwise it's 0, page number, so the page number of the segment, the max size, and the current size. So these are the sizes of the R segments. So some other extensions, InnoDB dictionary size limit. This is for in-memory. If you may have seen some stuff around if InnoDB data dictionary gets to use too much memory. This is a way that you can shrink the amount of memory, or you can set a limit on the amount of memory that the data dictionary can use. The InnoDB dictionary tables, this InnoDB dict tables here is a status variable. Again, it has an uppercase I. And it has the number of entries that are in the dictionary cache. So if you want to say, okay, should I increase it or decrease it, you can see how many are currently in the cache and say, oh, that's way too few, let me increase it. Or that's way too many, let me decrease it. InnoDB expand import. This is a little confusing. It's when you're doing an import table space. Basically, you can use a .exp file to change indexes quickly. I think it's a way to kind of change, like add indexes or change indexes without having a lot of downtime. Basically, what you end up doing is you have a data file, you import the data, and then what you do is you say, okay, discard the table space, and then import this new table space with the .exp, and the new table space has new indexes and stuff, and then magically you have indexes, and it's done asynchronously. Extra undo slots, there's a specific warning. So if you run into the warning that says cannot find a free slot for an undo log, then you will need to increase this. The default actually is 1024 undo slots. You can increase up to 4072 undo slots. The default actually is false, which means 1024 undo slots. It means don't increase it. It's not no extra undo slots. Which is just weird, to have false or a number. It's kind of like, why not just say 1024? I don't know. Why not just have a number of undo slots as opposed to extra undo slots? It's probably something having to do with how they patched it, where they do that. But, yeah, what can you do? At least you have the ability to make more undo slots. InnoDB overwrite relay log info. This is basically if you have a crash. If you have a crash after InnoDB committed the transaction on a slave, but before the replication, so when I said, okay, things write to the log buffer. You commit a transaction, things write to the log buffer, and then it writes to the InnoDB buffer pool. Well, on a slave, if you're replicating to an InnoDB table, what happens is it writes to the log buffer, and then it after that, it writes to the replication position. It's okay, I've done this one now. And then it writes to the data. So if you crash between the time when it commits the transaction in the redo log, in the InnoDB log buffer, and between the time that the replication position is updated, if you crash there, you may end up redoing that transaction because the replication position hasn't been done. So you might end up with duplicate key errors and all that kind of stuff. So, if this value is set to false, which is the default, you might end up having duplicate key errors. The reason that it's default by false is because if you do this, it will actually go to the next statement, and you might end up skipping a MyISQL table statement. You might skip it from other storage elements that aren't in InnoDB. Okay, so that's why it's the default, because you may not be 100% InnoDB, and it's not going to make assumptions. And again, that's how regular InnoDB works. If you set it to 1, the relay log file will actually be overwritten with the value, which is a later position in the relay log, because it's like, oh, I already did this. Well, look at my redo log. I've already done this. Let me change replication to be later. And that's it. So we're exactly on time right now. It is 4:56. Same deal, leave your business card, you could win a book. We'll invite you to read our blog post, follow us on Twitter, and join our next webinars. The drawing is going to be immediately after the talk once all the cards are collected.